Good afternoon, everyone. Thank you for joining our webinar today. We are hosting a webinar on how to accelerate your structural simulations, how to automate your pre-processing tasks, and how to do rule-based machine using SIMULIA software. So before I introduce our speakers, I want to give a brief introduction about our company, EDS Technologies. EDS Technologies is one of the largest technology solutions providers in India with more than 30 years of business transformation experience. We help businesses transform by enabling adoption of virtual twin, geospatial analytics, and 3D printing. We have in fact introduced many technologies like 3D printing, VR, digital manufacturing, geospatial analytics for the first time to the Indian customers. We are established ourselves as a trusted partner for more than 2,000 organizations across various industries, which includes automotive, aerospace, defense, industrial equipment, mining, and more. We have dedicated regional teams reinforced by our domain and functional consultants. We are backed by strategic alliances with global leaders who are pioneers in their respective technology areas. In India, we have a widespread presence with 11 offices, with our headquarters being at Bangalore. We hope and we aspire and we are an end-to-end technology solutions provider to our customers. So today we are joined by our customer from Hitachi Astemo India Pvt. Mr. Uday Singh Patil. Mr. Uday has over 14 years of extensive experience in product development, product design and development in automotive domains like engine components, interior plastic design, cylinder head gasket, elastomer gasket, and casting parts. Since joining Hitachi Astemo, Uday Singh has established the CAE analysis of the braking system. He has implemented the state-of-the-art simulation methods with the help of global team for all the Indian OEMs. His notable achievements include the CAE analysis of disc brake caliper and carrier opening and strength analysis. He has more than 6 years of experience working with Talbros for CAE domain using Abacus tool in R&D department. His work includes understanding the customer requirement for engine main sealing gaskets and other gaskets. Currently, he is working as Deputy Manager CAE at Hitachi Astemo India Pvt. He holds a Bachelor of Engineering in Mechanical Engineering from Shivaji University. So he'll be addressing us on how SIMULIA SBE role helped his organization address these challenges and the benefits their organization could accrue. So the next speaker is our technical speaker, Mr. Kedar Gokhale. Kedar is a senior application engineer with over 8 years of experience specializing in nonlinear structural dynamics, high velocity impact analysis, and crash simulations. He has successfully managed 3D Experience SIMULIA, Abacus, and eyesight projects and services across various industry verticals and handled multiple customer issues and escalations. So over to you, Mr. Uday sir.
Good afternoon, all. Myself Uday Singh Patil, and I am working here as a Hitachi Astemo India Pvt. Limited as Deputy Manager in CAE from June 2024. Yes, Kedar, next. Yeah. So I briefly introduce about our company. Hitachi Astemo was born in January 2021 from the merger of 5 companies: Hitachi Automotive Systems, Can, Shawa, and Nissin Koigo, and Kalyani Chassis Brakes. So with the merger of these 5 companies, which includes to strength and abilities to make significant contributions to safety, comfort, and environmentally sustainable technologies for mobility. And that's the name integrated with Hitachi plus Astemo, Hitachi Astemo. Yes, next. So thoughts behind Astemo is its name comes with 4 names as A for advanced, S for sustainable, and T for technologies, and MO for mobility. So Astemo together, we can say we will contribute to a sustainable society and improved quality of life by providing world-leading advanced mobility solutions that satisfy our customers. That's the name Astemo. Yeah. So here, these are the business verticals. In Hitachi Astemo, we will realize safe and comfortable mobility through technological innovations in case areas by the verticals like ADAS, powertrain systems, electric oblique engine, chassis systems, motorcycle systems, connections, software aftermarket, and power products with industrial equipments. So from chassis system, yes. So from chassis system division, our unit is brake business unit, and here the working company Hitachi Astemo India Pvt Limited, which is work in braking systems. So these are the main product portfolio of Hitachi Astemo's brake. So mainly we are working in disc brakes and drum brakes. So these are some four types of these disc brakes: ZOHE, ZOHE SPS, BIR, BIRF plus in drum brakes, drum and rotor and drums with ventilated solid disc as well as drum disc. And APB brakes, the new technology also we have in disc brake, that is caliper and carrier with this APB APB standards and DI. Yes, and the future brakes we have as a smart brake disc as well as smart brake drum and smart actuations. These are some futuristic brake products. Our company is working on this one, these products. Yes. So earlier in Hitachi, we are using for meshing as well as model preparation for simulation. We are using CATIA V5. Our global technology and global process is using CATIA V5 tools with FMS, which is for surface mesh FMS, and FMD for solid mesh for CA simulation model preparations. And due to these separate tools, different types of mesh like surface as well as solid mesh we have to prepare to make a analysis model preparation. And also we have to required another AFC tool to export that mesh, that model which is meshed in FMS FMD in CATIA tool. We have to export with another license AFC to convert it in export files. For example, for Abacus we can use input file.inp. So for other tools also it would be CDB and all. So it requires another tool for exporting also that mesh. So all tools required basic CATIA licenses for this CA engineer to perform model preparation for CAE, meshing, section, material assignment, connections and set creations and all. So where we have limited control and tools over the elements and nodes also to selections as well as to capture the critical areas of the geometry as per the casting parts and all. Yes. Okay. So this, yeah. So we have moved with this combination with the FMS and FMD to replace with 3D experience SIMULIA SB role, where we can mesh easily the CAD geometry. So this is one casting part which is caliper. So we can import it from step as well as CAD part or any other tool file name. So here we can defeaturing the geometries as well, where the names, champers or fillets which are included, you can defeature from your part names before do meshing, which are unnecessary to do meshing and all. So after that we have the meshing combinations with surface triangle mesh where we have both first as well as second order options, and then we can mesh it with various size, and we have uh, other parameters, edit all parameters, where we can editing as per our mesh and analysis requirement, where we have geometry as well as quality and maximum nodal deviations and number of nodes on the edge. These parameters we can set, and we can prepare the mesh on that parts. So it's easy in yes, 3D experience Simulia. We can firstly do the surface mesh, and after that we have to check the quality of that part, and we have different quality criteria. Yes, as per earlier in hypermesh also, that there are a lot of criteria with element minimum angle, maximum angle, Jacobian. For TET or 3D solid mesh, we have TET collapse or Jacobian, and then all. Warpage also one criteria. So here also we have in Simulia there are different element types as well as different quality criteria, where you can clear the mesh with your quality criteria for analysis. And we after having this surface mesh, we can do a solid tetrahedron filler, which is a tetra mesh, which is having yes, it will done with a quick time within. Yes, after that 3D solid mesh, we can use this group settings, node settings for boundary conditions as well as load inputs. Yes, for output also, where you need displacement or stress related area, where interested localized area, critical areas. So you can define these with selection of the node sets, manual groups, as well as where is having various tool options, which can choose with the node, element, as well as surface and whole. Yeah, element surface also, as well as full 3D element faces. Yeah, so these node sets, element sets, we can use it uh, for analysis, and it is very easy in Simulia to make it all the CA deck preparation with these tools. Yeah. And even though in CAD geometry, if it is linked with all CAD tools, as example, CATIA tool, this geometry and Simulia tool is linked. So if we change this one, any feature, if you want in future to change, let's say at bolt hole location, we can add a geometry with 30 mm. Both side, and we have to just rerun this analysis. Only this change is there in geometry. So automatically in this Simulia software, this part will mesh automatically update as per the past model criteria and parameters, mesh size. So this is the benefit of this Simulia software SB role, structural build role, where mesh can be regenerate, update, as well as it is linked with other tools like design tools like CATIA and others. So if you make any update in geometry on that software, it will automatically update here. Yes, see, these are the mesh updation with surface as well as 3D solid mesh. And after that, you can use this mesh model by exporting option. You can use, if it is Abacus, then you can use for input file.inp for analysis, even other softwares also, LS Dyna for crash analysis and Nastran and all. So we have exporting output options also. Those are for various different analysis tools like Abacus, Celestine, and Nastran. Basically, as per the global standards of Hitachi, we have to use these three tools like CATIA, FMS, FMD, and AFC, another tool for exporting that mesh model. So we have replaced these with one meshing tool of the SIMULIA SBE role, which is having all types of meshing available in single SBE role, and it gives control over specific element and nodes. Export option is available with same GUI. More meshing features like ruled mesh, mapped meshing, and ruled connections are beneficial in the same role. Easy to manage mesh and connections through feature management. Seamless integration between CAD and CAE. Seamless integrations with existing 3D experience platform, and parametric capabilities with mesh changes. So that's why Hitachi has decided to use this one for assembly as well as single component meshing as well as analysis for this SB role SIMULIA. Thanks.
Thank you, Uday sir, for the very insightful presentation. Now over to you, Kedar, for the technical presentation.
Yes, sure.
Thank you.
Okay.
Thank you, Abhay, and thank you, Uday, for the brief knowledge sharing session on this. How is it useful to you or and your organization, and how it is reducing time in the model preparation. So I'm going into the little bit technical details of this particular SBE role. So my agenda will be, we'll see first automated mesh generation, and rule-based techniques, how we are going to use that, and what are the benefits, what are the options you are getting in that. Then optimizing the assembly and connection with the feature management manager. So in that, how we can quickly change the meshing size, how we can change the connection type or bolt diameter, and how we get the control to optimize the connection and mesh management. Then we'll see the associated with the finite element solver, which type of files can be exported from this particular meshing role or the SBE role for the analysis that we have already seen, but we'll focus on put a light on that. Then particularly how this particular CAD and CAE integration will work, how it is useful. We'll see that particular demonstration in this particular session. So I'm going to show you the how the rule-based meshing techniques will be used in this particular SBE role. So while creating a role, you will get a different types of mesh options. So here you can see you can do or create a role for a rule for the octree triangle mesh, or the tetrahedral mesh, surface triangle mesh, surface chord mesh, sweep mesh, beam mesh. So each and every mesh type is covered into the meshing rule. Then once you select the meshing type for the rule, then you will go into the details, which type of element order you want to create, then what will be the mesh size, global mesh size, as well as the minimum mesh size and the maximum mesh size. In the quality criteria, you can set the minimum triangle, maximum chord angle, minimum chord angle, then the warpage, skewness you can set into the quality criteria. Then what type of geometry you want to capture into the while doing a meshing, that you can choose by doing setting angles for selecting the faces or the curves. Then you can, if you want to put a washer around a hole, you can select a particular feature type, and you can set how many number of elements you require around a hole. You can set that into the feature option. So we are going to see this particular demonstration in detail, how we are going to use that. So for this, I use the cradle, automotive cradle assembly, in which you can see the surface components are there, and the welding location surface or the seam weld location, point weld locations are there by here you can see with the blue lines. So these are the weld location and the weld points on which we need to create a connections also. Also there are bolting locations also, in which we need to create a bolted connection. and we can create a rule for the connections also, as well as the meshing also. So here we are going to see the how to create a rule for the mesh and how it is useful for the mesh creation. So I'm going into the automated FEM, in which we need to create a rule first, and it can be used any type of geometry in a future. Suppose you are importing a different part, you can use the same rule for the meshing. So once you created a rule for the mesh, you can use it at any time. It will get saved into the 3D Experience platform. So here I am generating a particular surface quad mesh rule. Here I am selected a mesh type as a mix mesh, and element order will be a first order element, and mesh size will be a around 10 mm. So here you get different types of mesh: quad dominant, mix, and tria dominant also. So here I am setting a mesh size to 5 mm. Then the mesh technique I am set it as a default for this. Then growth ratio also you can define 1.41 or anything whatever you require. Then capturation of the geometry, here I am setting the capturation limit. I just increase that with the 45-degree angle, so each and every surface will get considered and get selected. So this is my quality criteria. Minimum length will be 2.5, 10, and angle criteria. Then the maximum nodal deviation from the geometry, it is from the free edge and from the geometry. So we need to limit that particular the deviation. For that we can set the tolerance. Now here we are setting up the rule for the washer around the hole. So here I have given clear the 0 to 10 mm holes, and here from 10 mm to 100 mm holes, I want to put the minimum 8 number of elements or the 16 number of elements around the hole. So that particular setting I am doing into the particular rule. So one layer is sufficient for me, and layer height of the layer will be a 5 mm. So I've created this particular rule, and it will get saved into the platform. You can fetch it at any time while doing a meshing, and you can apply it to your particular part, and you can automate your meshing with the rule mesh. So this particular mesh rule is created. Now I am going to assign this particular rule to this particular all the parts available in the assembly, and we are going to create a particular automated mesh. So for that I will go into the automated FEM. In that I will create a advanced option for the automated meshing. Here I want to select the procedure. So I will be using a surface quad mesh. Then it will be applied on the all available parts, and selection will be on a main body. So main body of the part, the particular surface mesh will get applied, and support for that particular mesh or the body will get it from the available publications link into that particular geometry. Now we need to select that particular generated rule. So here I am selecting that particular generated rule for the surface mesh. So I am fetching it from the library which is already saved. We have created and saved it. So this is available. Now I'm selecting that particular rule. Once you have selected, this particular criteria get applied to the particular meshing style. So this is done. Now here we get some options for the settings to do exclusion or the inclusion of the mesh and all. So particularly quality criteria and all, if you want to fetch it, you can do it, and automatically export option is also there. Then once this setting is done, I am setting OK. I will do this automation. Now you can see the particular mesh part are found, 11 parts are found, and there are some parts that are the welding lines that need to be excluded, that not required a shell mesh or anything mesh required. So I'm going to exclude that particular weld line parts from the meshing automation, and I'm going to run it. So after running it, it will execute step by step over the each and every component. So this particular process you can see in the process bar. So out of 10, 0 parts are meshed. So once it get progress, you will see the one part is meshed, second part is meshed, and if it get failed according to that particular rule, whatever we have said, it will get reflected into the failed FEM parts. So once it is done, we can view the mesh, how it is get captured, how geometry is get captured, is that the mesh around the hole is maintained or not, how the washer get placed around the roll. So now you can see the process or the progress in a progress bar. So 3 out of 10, 4 out of 10 part got meshed. So like this, it will get processed. If your assembly is made up of 100 or 150 parts, it goes step by steps. Now you can see the particular report in that zero error found and all parts got meshed. So once you say yes, done, you can see the particular mesh in the background. So I'll say okay, and we'll view the mesh. So after applying the particular shell mesh or the rule mesh with the surface quad element, you get this particular mesh. And if you want to edit this particular mesh, you can go individually to that particular component and you can edit it from the feature manager. We are going to later it in a later session, we are going to see it how to use. So here mesh around the hole, we have set it as a 8 number of elements that has been achieved. So minimum 8 number of elements we put it. So that particular criteria is achieved, and washer around each and every hole is what placed. So this is a particular quality for the particular mesh, automated generated mesh. Similarly, you can do the connections just like creating a bolted connection or a line fastener, line welding, or the surface welding or the point welding. You can create by rule-based connection template. So in the rule-based connection template, similarly, you need to specify what type of connection you want to do, what will be a head diameter, nut diameter for the bolting connection, what will be the construction of the mesh and all. And this is the particular settings you can do into the rule-based connection. So similarly, you will get options what kind of geometry you want to capture and all. You do that particular settings and you run the particular rule for the geometry, and it will create a connections from that particular by maintaining that rule. So it will looks like a this we have generated by using a rule-based connection. So here the particular welds have generated with the shell mesh. Then the particularly here you can see in a curvature area this particular weld elements got created. Then you can see the bolting elements also, welding elements also. So here we can see the particularly shell welding element in this particular section like this. So all over the where the line is drawn for the welding, their weld got created. So it will not miss any geometry. Where you specify the welding line at that particular location, it will generate a mesh with the specified criteria. So here you can see at each and every location it got created. Here a 1D a particular beam element also got created for the welding connection. So in some section we have created a beam welding element, and in some section we have created a shell welding element, and according to that it got created. Then these are the bolting connection we have created for this. So according to the node and head diameter, it got created according to the hole size. So welding connection as well as the bolting connection are also got created by using the rule-based connection method. Then once you're done with the particular meshing and the connection, later on if you want to go at the specific location and you want to change it, you can easily do that by accessing through the particular feature manager. So for the meshing, it will be a mesh part manager in which you can see which type of mesh is there and what will be the size. If you want to increase the mesh size, you directly go in this column, you can change the particular size and you can regenerate the mesh for that particular individual component also. Here also in the line fastener or the particular surface fastener or the virtual bolt connection, you can create or edit the particular connection or the welding definition by accessing through the connection manager. So we'll see the particular demonstration in the video. So this is the particular connections and mesh geometry. So we are into the connection manager. Here line fasteners are there, nothing but the shell welding geometry. So if I want to edit it by, I want to add it or I want to make some changes in that. So I will easily access that particular thing. If I want to change the material, I want to change the component at that particular location, I can do that by accessing through the feature manager. So here you will get all of the editation option which are available in individual definitions also. So here will be the 3 mm. You can increase it or the decrease it. So similarly, you can have access to the bolting connections also. Suppose if I edit this particular bolt connection, here you can see edges I have selected automatically. So here you can change the definition, bolt and all that, and the diameter of the bolt, hedge diameter and all that. Then if we go into the mesh manager, here you can see the particular what type of mesh is applied to that particular component, 2D mesh, 3D mesh, then the type of the element. So surface quad element is applied. So here you can see. Then if I want to edit it individually, I will go and click on edit and I can access the particular edit button. So it will overrule that particular applied rule and it will take this a particular definition which is edited in a recent access, and it will apply that particular definition to the particular mesh. Then you can change the color of the particular mesh component also for the better viewing and better checking of that particular mesh generated model, and you can view that. So this particular thing you can manage it from the mesh and the connection manager or the feature manager, and you can easily pick that particular part and the connection and you can easily edit it. Then it has a very good feature, that is a assembly of mesh. Once you imported the particular assembly into the SBE role, it will create a top one FEM representation in which all the other part FEM will get called. So here you can see the particular diagram. This particular assembly have this particular assembly of mesh. So this is the top one FEM representation and it get linked with the other part FEM. So suppose your assembly containing 3 parts. So 3 parts have their individual FEM and that individual FEM get linked with the assembly FEM. Suppose in the future you want to do a FEA analysis with the single part, then you will go into the single part, you will fetch this particular mesh and you can do a particular analysis. So at that time you don't need to remesh it again, that particular single part. So that benefit you are getting, your mesh or the APM representation always link with your part, and whenever it is get called, it will get with that particular FEM. Suppose this part will be get used into the other product line. That part, when you assemble it into that particular product line in the CAD, it will go with the FEM. Whenever you want to do a particular FEA analysis in that particular mesh, you can use. So reusability of the particular FEM representation can be done and no need to do a repetitive meshing. So we'll see the quick demo how to linking process happen and how you quickly generate a assembly of mesh. So this is particularly drone part or the drone assembly of drone we have taken, and we have created an individual mesh for the individual components of the drone. So suppose this is the arm of the component, this is the base part of the component, then the motor, then the rotor blade shaft, and then the rotors, then the stands. Now we want to assemble it. If we are going to use the preprocessor which is available in the industry, in that you need to call it this particular mesh, and you need to arrange it just like a reflect it, rotate it, or the position it at the other location. Now here I am just linking the FEM with the CAD. Once I link it, this FEM go into the assembly and sits where it required. So here in the part 1, I'm just selecting that base FEM I need to link with this part 1. Then this part 2, again base I want to link it, so I will link it. Now here 4 arms are there, so I don't need to link it separately. I will link it, saying link it at the all instances. So all 4 arms will get placed at that particular location. Similar with the motors also, then the color of the motors, rotor blades. So repetition of parts will be there. You can quickly arrange this particular assembly of mesh, and you can quickly create your required mesh for the analysis. So you don't waste or the consume your time for the rotating it, reflecting it, positioning it. No need to do that. It will take automatically from the linking. So here in the background, assembly of mesh is ready for the analysis. Now you can define your connection and you can do your analysis with this particular mesh geometry. Now we'll see the particularly associative with the CAD. So Uday has already explained that particular very good and beneficial feature. When you update the geometry, your mesh will automatically get aligned with the updated geometry. So you don't need to remesh it or apply the mesh, then check the quality criteria. All things need not to be done. So here I'm changing this particular pattern into the slots, so we can have some mass reduction into the arm. So we'll remove this particular triangle pattern and place the particular slot section. So here I have replaced this particular pocket section with the slots one, and now I want to use this particular slots for the analysis, or this particular updated design for the analysis. Now I'm going into the mesh. Now here you can see the mesh is not aligned with the updated CAD. Now I will go into the mesh and will just say update, and it will automatically get aligned with the geometry. Now you can have a specific question: can it be happen with the shell mesh, or can it be happen with the hex mesh? Yes, it is possible. You can do that particular thing with the hex mesh also and the shell mesh also. You can have this particular feature associated with the CAD, you can have it. So by using this particular feature, you can explore your particular part design in a different way. You can have a quick iterations for the quick analysis of this particular product, and you can quickly review your design. So these are the benefits. Then once you're done with the particular meshing and connection and all these things, you can export this thing in a different format. So particularly SB or the SIMULIA SB role is not restricted to the Abacus output. It can give you the .key format or the .k format, which will be used into the LSDyna, or the .bdf or the .nas format, which can be used for the Nastran solving. So here you don't have any restrictions for the solver. You can solve it into the Abacus also, Nastran also, LSDyna also by exporting this particular mesh, as well as into the PAMcrash also, because once you export the particular INP file, it can be imported that INP file into the Nastran. So no worries about the solver, you can quickly use. So no restrictions on the solver. You can have this particular mesh tool which is linked with your CAD. Once CAD get updated, your mesh will get updated. You will get updated mesh and you can solve it in this particular mentioned solver. So by having a SB role, we can have different types of benefits. So first, you will get associativity with the different CAD tools. Whatever CAD tools you have, we can connect with them. We have a different CAD connector with us, so we can connect a particular SBE tool with that particular CAD tool. Then in this particular SBE role, there is a build finite element model efficiently using the meshing rules, then the managing the sub-assembly connections and generating a weld connection, and reusing the re-engineering design data. So you can reuse your generated mesh earlier, orphan mesh you can use for the analysis. Then you can manage the sub assemblies and utilize the automated assembly connection modeling, which we have seen the rule-based automation procedure. You can implement it. Then you can generate an abstraction shape, just like if you want to generate a mid surface, or if you want to remove a particular small fillets, chamfers, you want to remove the logos from the particular geometry, you can do it into the SBE role. No need to go back to the CAD tool or the geometric cleanup tool. These are the available inbuilt into the SBE role. Then it will be a collaborative model management for the building and sharing the models, particularly suited for the large assembly. Suppose you have a 150 or 200 parts assembly. In that particular assembly, you need to generate a mesh very specifically. In that, you can do automation for the meshing and the connection area, and you can reduce your time for the simulation as well as the pre-processing. So that's all from my side, and I will thank you for attending this particular session, and I'll also thanks Uday for the exploring this particular tool and giving us the what are the benefits you are getting this particular tool, and what are the advantages, what are the previous processes you are following, and what are the how you have overcome these challenges by using the SBE tool. So thanks a lot from EDS, and that's it. You can have ask any question.
So first of all, I would like to thank Uday sir for taking his time out from his busy schedule and joining us for our webinar today. His presentation on the challenges their organization had and the benefits they could accrue using the SIMULIA SBE role were very insightful actually. I would also like to thank Kedar for giving us a very informative presentation. We do have some more questions, but due to paucity of time, we can take it later one-on-one. I would also like to thank the audience for taking their time out and joining us for this webinar. If you have any further queries related to the SBE role or any other simulation requirements, you can connect with us. Our credentials are displayed on the screen right now. Please mail us or contact us, and we'll be happy to help you on your queries. So once again, I thank you everyone for joining us. See you at the next session.